Yellowstone isn't just a national park. It is one of the largest active supervolcanoes on Earth, and scientists say it's already 40,000 years overdue for its next massive eruption. The last time it erupted, it reshaped the continent, choking the skies with ash and plunging the planet into a volcanic winter. If it happened today, entire cities could be buried, crops wiped out, and the global climate thrown into chaos. Experts are now warning that Yellowstone may be quietly preparing for something far bigger than we realize. The sleeping giant. When most people think of Yellowstone, they picture geysers shooting into the sky, bison roaming freely, and breathtaking landscapes. But beneath that beauty lies something far more dangerous: a massive supervolcano, one of the largest on Earth. Instead of a cone-shaped mountain like Mount Fuji or Vesuvius, Yellowstone is a vast caldera, a giant bowl-shaped depression nearly 45 miles wide, formed by catastrophic eruptions in the distant past. What looks like a paradise above ground is, in reality, the surface of a sleeping giant. Scientists have identified at least 3 colossal eruptions in Yellowstone's history. The first, around 2.1 million years ago, created what is known as the Huckleberry Ridge eruption, blanketing much of North America with volcanic ash and leaving behind scars that stretched across hundreds of miles. The second eruption occurred 1.3 million years ago, forming the Island Park caldera and reshaping large parts of Idaho. The most recent, about 640,000 years ago, was powerful enough to eject over 1,000 cubic kilometers of rock and ash into the atmosphere. That eruption created the Yellowstone caldera we see today and spread ash so far that traces have been found as distant as the Gulf of Mexico. Each of these events wasn't just a regional disaster, they were continental-scale catastrophes. Entire ecosystems were destroyed, climates shifted for years, and species either adapted or vanished. These eruptions remind us that Yellowstone doesn't erupt often, but when it does, the results are earth-changing. This is where the unsettling idea of Yellowstone being overdue comes into play. On average, there seems to be about 600,000 to 700,000 years between major eruptions. Since the last eruption was roughly 640,000 years ago, some scientists note that we've crossed the point where another event could be expected by as much as 40,000 years. However, it's important to understand that geological time doesn't follow a human calendar. Overdue, in human terms, suggests urgency, but in the language of Earth's geology, it may mean thousands or even tens of thousands of years. The science of prediction. If Yellowstone is truly a sleeping giant, then geologists have taken on the role of watchful guardians, monitoring its every move. The United States Geological Survey, USGS, and a network of scientists have transformed Yellowstone into one of the most closely observed volcanic systems in the world. Their tools are highly sophisticated, designed to catch even the faintest signs of restlessness deep underground. One of the primary methods involves GPS monitoring stations placed around the caldera. These devices can measure movements in the Earth's crust with astonishing precision, down to just a few millimeters. Over the years, these instruments have shown that Yellowstone's ground rises and falls, almost like the slow inhaling and exhaling of a massive creature. This breathing ground is caused by shifting magma and gases beneath the surface. Sometimes areas of the park uplift by several inches in just a few years, only to sink back down again. Such fluctuations remind scientists that the magma chamber below is dynamic, alive, and constantly in motion. Alongside GPS, seismographs record the hundreds of small earthquakes that ripple through the Yellowstone region each year. Most of these quakes are too weak to be felt, but they act as important signals. Clusters of quakes, known as swarms, can indicate that magma or hydrothermal fluids are moving. In fact, Yellowstone has experienced swarms involving thousands of quakes over the course of just a few months. While most pass without incident, they are reminders that the system is far from dormant. Another critical tool is the measurement of gas emissions, especially sulfur dioxide and carbon dioxide. Changes in the levels of these gases can reveal activity beneath the surface. A spike in emissions might suggest magma is rising closer to the surface, releasing its trapped gases into the atmosphere. Recently, scientists have also noted patterns of ground deformation, unusual geyser activity, and increased seismic swarms. But here lies the greatest challenge. None of these signs necessarily mean an eruption is imminent. Yellowstone has shown similar patterns before without erupting. Volcanic systems are complex, and even with cutting-edge technology, prediction is far from exact. In the end, scientists can't pinpoint a date, year, or even century. What they can say is that Yellowstone is active, restless, and powerful, and when it finally does erupt, the world will have little time to react. What an eruption could mean for the U.S. If Yellowstone were to erupt today, the immediate devastation across the American West would be almost unimaginable. Unlike the gentle lava flows people often associate with volcanic activity, a super-eruption would unleash a deadly mix of ashfall, pyroclastic flows, and magma explosions powerful enough to erase entire regions. Within minutes, pyroclastic surges, walls of superheated gas, ash, and rock moving faster than a jet plane would sweep across parts of Wyoming, Idaho, and Montana, destroying everything in their path. Cities and towns closest to the caldera could be obliterated before residents had any chance of escape. The ash itself would be one of the most devastating aspects. Scientists estimate that a super-eruption could send millions of tons of ash high into the atmosphere, where winds would carry it across the United States. Within hours, states like Montana, Wyoming, and Idaho could be buried under several feet of ash, collapsing rooftops, clogging rivers, and suffocating livestock and crops. Further out, major cities like Denver, Salt Lake City, and even Chicago could see inches of ash, enough to paralyze transportation and cripple basic infrastructure. The impact on infrastructure would be catastrophic. Power lines would collapse under the weight of ash. Water systems would be poisoned, and roadways would become impassable. Air travel would grind to a halt as jet engines clogged with ash, leaving the skies empty and cutting off emergency aid. Communication networks would fail, isolating entire regions. Survivors would find themselves in a world suddenly cut off from electricity, clean water, and reliable food supplies. FEMA has modeled worst-case scenarios, and the results are chilling. In such an event, tens of thousands of Americans could die almost immediately, while millions more would be forced to evacuate. The economic cost would be measured not in billions, but in trillions of dollars. Even regions spared from direct devastation would feel the effects as supply chains collapsed, agriculture failed, and essential goods became scarce. For the U.S., Yellowstone erupting wouldn't it just be a natural disaster? It would be a national crisis unlike anything in history, testing the limits of government, emergency response, and human resilience. And that's only the beginning, because the effects wouldn't stop at America's borders. Global fallout. While the immediate devastation in the United States would dominate headlines, the ripple effects of a Yellowstone super-eruption would quickly spread across the globe. The most far-reaching consequence would be the onset of a volcanic winter. When millions of tons of ash and sulfur dioxide are blasted into the stratosphere, they form reflective aerosols that block sunlight from reaching the Earth's surface. Temperatures could plummet worldwide, with some regions experiencing drops of 10 to 15 degrees Fahrenheit within months. Such a shift would be catastrophic for global agriculture. Crops rely not just on warmth, but also on steady sunlight, and a volcanic winter could lead to widespread crop failures. Corn, wheat, and rice, the staples of billions, would wither in the cold and dim light. Livestock would starve as grazing lands became barren, and fisheries could collapse as altered temperatures disrupted marine ecosystems. Hunger and famine would spread on a scale humanity has not faced in modern history. history offers us a chilling comparison. In 1815, the eruption of Mount Tambora in Indonesia, far smaller than what Yellowstone is capable of, released enough ash to plunge the world into what became known as the Year Without Summer. Crops failed across Europe and North America, leading to food shortages, soaring prices, and widespread suffering. Famines and disease outbreaks followed. If a single eruption in the 19th century caused such disruption, the eruption of Yellowstone in the 21st century would be exponentially worse, with far denser populations and a global economy reliant on delicate supply chains. Trade would collapse as shipping lanes became clogged with ash fallout and infrastructure failed. Economies would spiral into chaos, stock markets crashing as uncertainty consumed nations. Energy production, especially solar power, would plummet under darkened skies. Countries dependent on imported food would face social unrest, and mass population displacement could trigger unprecedented waves of migration. Refugee crises would overwhelm borders, sparking political conflicts and reshaping global alliances. In essence, a Yellowstone eruption would not be a national disaster. It would be a civilizational event, one that could challenge humanity's very survival. The world has seen volcanic winters before, but never in a time as globally interconnected and fragile as today. What scientists are saying now? Headlines often scream that Yellowstone is 40,000 years overdue for a super-eruption. And while the statement grabs attention, scientists warn that it oversimplifies a far more complex reality. The idea comes from looking at the average time span between Yellowstone's last three major eruptions, roughly 600,000 to 700,000 years apart. Since the last eruption was about 640,000 years ago, some interpret this to mean we've crossed the deadline. But in geology, averages are not schedules. Volcanoes don't run on human calendars, and being overdue is more of a popular myth than a scientific certainty. The U.S. Geological Survey, USGS, has been clear. The probability of Yellowstone erupting in our lifetime is extremely low. This gap between public fear and scientific caution often fuels sensationalism. While doomsday theories spread online, volcanologists emphasize that Yellowstone is behaving much like it has for thousands of years. The earthquakes, geyser eruptions, and ground movements often cited as signs of impending doom are, in fact, typical of a living volcanic system. Yellowstone is active, yes, but activity does not mean catastrophe is imminent. Current monitoring results provide valuable reassurance. GPS readings show that the ground does rise and fall, but these movements are relatively minor compared to what would precede a major eruption. Seismic swarms occur frequently, but they are usually small and short-lived. Gas emissions are monitored constantly, and while fluctuations occur, they remain within expected ranges for an active volcanic field. Still, scientists don't dismiss Yellowstone's potential. They remind us that while the probability is low, the consequences of a super-eruption would be staggering. This is why the Yellowstone Volcano Observatory continues to watch the caldera closely, using satellites, sensors, and fieldwork to ensure no early warning sign goes unnoticed. The truth lies between hype and denial. Yellowstone is not a ticking time bomb set to explode tomorrow, but it is also not harmless. It is a restless, living system, one that will erupt again someday, though no one can say exactly when. Human preparedness and survival. If Yellowstone were to erupt in our lifetime, the most haunting question wouldn't it just be what happens next? It would be, are we ready for it? The answer, according to many experts, is unsettling. While the U.S. government has disaster response agencies like FEMA, no nation on Earth is truly equipped to handle the collapse of agriculture, mass migration, and a volcanic winter that could last for years. Unlike hurricanes or earthquakes, there is no full-scale evacuation plan for an event of this magnitude. The scale is simply too vast. Could humanity survive such an event? The short answer is yes, but survival would look very different from life as we know it. Entire regions of the United States would likely become uninhabitable, forcing millions of people to migrate to safer areas. International borders would face pressure from waves of climate refugees, and nations would be tested on their ability to cooperate or compete for scarce resources. Survival would hinge not only on preparation, but also on global unity in the face of chaos. Strategies for survival would revolve around food, water, and energy. Governments and communities would need to prioritize long-term food storage, grains, beans, and other storable staples capable of feeding large populations during agricultural collapse. Hydroponic farming and underground greenhouses could help sustain food production when sunlight is scarce. Migration would become inevitable, with populations shifting toward regions less affected by ashfall. Meanwhile, technology could play a crucial role. Renewable energy, satellite communications, and global supply management would be lifelines in a darkened world. History provides lessons, even from smaller-scale volcanic disasters. The 1980 eruption of Mount St. Helens taught us about the speed at which pyroclastic flows can obliterate landscapes. The 1991 eruption of Mount Pinatubo in the Philippines cooled the Earth by nearly a full degree Celsius for over a year, offering a glimpse into how even a mid-sized eruption can alter global climate. These events remind us that volcanic eruptions are not just geological curiosities. They are civilization-shaping forces. In the end, survival would not come down to government plans alone, but to human adaptability. Technology, cooperation, and resilience would decide whether humanity merely endures the aftermath of Yellowstone or finds a way to rise from it stronger. Yellowstone may not erupt tomorrow or even within our lifetimes, but scientists agree it will erupt again one day. That certainty is a chilling reminder that humanity's story is written alongside forces far greater than ourselves. Technology may buy us time, but it cannot silence the Earth. Our survival depends not only on preparation, but on humility, recognizing the immense power beneath our feet. Yellowstone is both a threat and a wonder, urging us to respect, study, and never underestimate the planet we call home.